All right. Algebra 2, Lecture 118 and 119, OSA 2A17. The student will determine if a sequence is geometric. Remember, the sequence is just a row of numbers with commas in between them. And we're going to find out if it's geometric instead of arithmetic, which is what we've been doing the last couple of days. We're going to find the common ratio, and we'll talk about that here in just a second, of the geometric sequence. A given term, the 8th term, the 10th term of the sequence, the 100th term of the sequence, whatever they ask us for. We're going to find that, and we're going to write the explicit form of a geometric sequence. I like to do this early and then find whatever term it is we're looking for, because we use the explicit form to find the nth term. So we're going to keep all of this in mind as we go about our business. A sequence is geometric if the quotient, that means you're dividing, of two consecutive terms, of the consecutive terms, those are the terms right next to each other, is constant. If you divide the terms and you get the same number every single time, then your sequence is geometric. So that's what we're going to do here. We're going to be checking that. Determine if the sequence is geometric, so I'm going to divide the terms, see if I get the same number. If it is, find the common ratio. That's what we'll get when we divide the terms. A ratio is what we get when you divide. And the 8th term in the sequence. Now on the worksheet today, you won't be looking just for the 8th term. You might find the 10th term or the 20th term or the 100th term. But for our lecture, we're just going to use the 8th term. And the explicit formula. And here's the general case of the explicit formula. A sub n, that's the nth term, is the first term. Remember, a sub 1 is the first term, times r, that's the common ratio, to the n minus 1. This is the general form, and we're going to make a specific form and use it to tell us what the nth term will be. In this case, it will be the 8th term. So here we go. I'm looking at this. I've got the first term, a sub 1, second term, third term, fourth term that I'm looking at. And I want to first of all determine if this is geometric. So I'm going to take, just like we did with arithmetic, to check for arithmetic, you start with the second term and you divide it by the first. So with arithmetic, we would subtract. We're looking for a common difference. Now we're looking for a common ratio. So what I'm going to do is take the second term and divide it by the first term. I get a 5. I take the third term and divide it by the second term, and I get 5. I take the fourth term and I divide it by the third term, and I get 5. And this pattern continues on forever. So what I've got is a common ratio. So I say yes, it is a geometric sequence. We're going to determine that the sequence is geometric, and we just did that. That's how. And if it is, then we're going to find the 8th term. Well, in order to do that, we have to have the explicit form, which is right here. Explicit formula, a sub n is equal to a sub 1, r to the n minus 1. That's our general case. And we're going to look for a specific case. We're going to look for the 8th term, because that's what they asked us to do. Now, again, you might be asked to find the 20th term or the 5th term or something like that on the worksheet. It won't always be an 8. So here we go. I'm looking for the 8th term. So that's a sub 1 is the first term, 4. R, we just found, was 5, the common ratio. And n minus 1, well, n is the term we're looking for. We're looking for the 8th term. So I'm going to plug an 8 in here for n. And 8 minus 1, I'm going to rewrite that here in just a second as 7. Just simplify it a little bit. A sub 8 is equal to 4 times 5 to the 7. And then we'll just do that with our calculator. And that'll give us the 8th term in that geometric sequence. There we go. 4 times 5 to the 7th power equals 312,500. So the 8th term in this sequence, if I haven't made a mistake, 312,500. Here's my sequence. There's the first 4 terms. If I keep multiplying by 5, on the 8th term, we'll be at 312,500. And let me see if I got that right. Yay! So that's how you work them. Let's do another one. The numbers can be negative, that's no big deal. You just do the exact same thing. We check to see if we have a common ratio, check to see if it's geometric. It's just looks like a sequence, so we'll see if it's a geometric sequence. Negative 15 divided by negative 3 is positive 5. We've got 5 again, how about that? Negative 75 divided by negative 15 is positive 5. Negative 375 divided by negative 75 is positive 5. So yes, this is a geometric sequence. And again, you're going to be doing multiple choice, so it won't say yes, but it might say no, it's not a geometric sequence. So if we didn't get a common ratio, we would say no, it's not a geometric sequence. But this one is. So now I'm going to find the explicit formula and then use the explicit formula to find the 8th terms, because that's what they're asking us for. Again, on your worksheet, you might be asked to find the 10th term or the 20th term or something like that. Here we go. Here's the explicit form. The general case is a sub n is equal to a sub 1 times r to the n minus 1. I'm looking for the 8th term. So a sub 8, the 8th term in the sequence, is the first term, which is a negative 3, times 5 to the n minus 1. And that will be 8 minus 1. Whoops. Clean that up a little bit. N is 8. The 8th term is what we're looking for, 8 minus 1. So again, that will be a sub 8 is equal to negative 3 times 5 to the 7th. Alrighty, and we'll do that, perform those operations with our calculator. And we get negative 200 $34,375. All right. So we found that this sequence, this row of numbers, does have a pattern. It's geometric. Found a common ratio. And we use that common ratio and the general form of the explicit formula to find the 8th term, which is what we were asked to do. Okay? So these are the things we were asked for. Yes, it is. We found the explicit form. This is, and we found the 8th term. Okay. Let's make sure I haven't left anything out. Determine if it's geometric. Yes, it is. If it is, find the common ratio. We did find the common ratio too. Where did I find that? I didn't write that, but I should have. R equals 5, because we were asked specifically for that. So there it is. I used it, but I didn't identify it. I think I did that over here. Here's what we're looking for. R is 5 in this case, again. And here's our explicit formula that we're looking for, and the 8th term. These are what we were asked for after we determined that it was geometric. Okay? Now let's take a look at another one here. Got 2 more. I'm going to check to see if it's geometric. 11 divided by 6 is not 2, so I'm going to stop right there. It's not geometric. In a multiple choice, I would find the choice that says not geometric. Okay. So we move on to the next one now. And here we have every other term is negative. That's no problem. We just divide. 16 divided by 4, negative 16 divided by 4 is negative 4. Negative 64 divided by negative 16 is negative 4. Negative 256 divided by 64 is negative 4. So we do have a common ratio, which means yes, it's geometric. The common ratio is negative 4. Now I'm going to find my explicit formula using the general case. A sub n will be, again, I'm looking for the 8th term because that's what my instructions said. And again, you may not It may not ask you for the eighth case on the worksheet, the eighth form on the worksheet. Eighth term, I'm sorry, I can't speak this morning. Looking for the eighth term on the worksheet, they may ask you for a 10th term or a 20th term or whatever. I'm looking for the eighth term. A sub 1 is the first term in the sequence. Times negative 16, I'm going to put that in parentheses so it doesn't look like 4 minus 16. 4 times negative 6. I just messed up. The first term is 4, and R is negative 4. I said negative 16 because of brain damage. Negative 4 to the n minus 1. Well, that would be 8 minus 1. Because I'm looking for the eighth term. And I perform those operations with my calculator. A sub 8. 4 times negative 4 to the 7th, because 8 minus 1. Take my calculator. And I get negative 65,536. Hopefully that's correct. I'll check the key in just a second. Negative 65,536. Yay! I want you to look here. If my R is negative, 4 times negative 4 is negative 16. Negative 16 times negative 4 is 64, positive. Positive 64 times negative 4 is negative 256. So every time I'm multiplying one of the terms by negative 4 and getting the next term. So my terms are going to alternate in sign, and that's just fine. It's going to go positive, negative, because my common ratio is a negative 4. I got that by dividing the second term by the first. So if I multiply the first term by the common ratio, I get the second. If I multiply that by the common ratio, I get the third, so forth and so on. If the common ratio is negative, the sign of your terms will vacillate between positive, negative, positive, negative, positive, negative. Okay? And that's basically what we're doing today. You can do this.